Hi everyone. I've got a universal joint here from a 1911 Willys Overland. Now this one, everything inside had just gone all hand grenade and it was nothing but shrapnel on the inside. So the owner welded it all up in a couple of spots where it was worn and broken, and I've set it up to mill off that weld and maybe a smidge of the parent material just to true everything up. I showed the setting up of this on a short video that you can find on my channel, but basically I just put a couple of pins on the T-slots and then parallel on the two flat sides that are still intact, and I bumped that parallel up against the two pins. That got me aligned this way with the table travel. Now I need to get this centered so that I can get everything nice and true. Not a lot of great places to do that though. Obviously I can't use the outside because the clamps are in the way. I can't use this boss because of the cutouts, but there is a very small surface right on the inside that's in pretty decent shape as far as I can see, and I'm going to use that with a coaxial indicator. Before we get into that though, I thought I'd show how this is all supposed to work. This is the other half of the universal joint, and this is actually mostly what exploded on the inside. You can see that it's been welded back together, and the owner has gone ahead and turned down these two trunnions. Onto the trunnions is supposed to be a square fitting. I've got a square nut here just for demonstration purposes, but it slides over that and will move up and down in these slots, as well as of course drive it. It acts like a drive key. And meanwhile, as the rear axle moves up and down on the suspension, it allows this to move in and out, rotate of course, and also pivot side to side. It's a pretty neat design. But before we can get it running again, we need to get all this weld off on the inside. So let's get cracking. What I'm doing is just moving the table a little each way and then slowly bringing it back in until I see the bare minimum of movement. And one more time in the Y. I think that's going to be good enough. I know where I am on the center line of the part, so I just need to move my end mill over the same distance each direction and use that to cut my slot, and I should be guaranteed to get a nice centered slot. Now that I've got this all machined out, I'm using an adjustable parallel to check the size. So I'm going to get that stuck in there and tightened up with the two screws. And now I'll be able to come in with a micrometer and see how big this slot is. And it looks like I'm just shy of 1.190. I'm about 1.189 and 6/10. So now I've got a target dimension for the trunnion blocks, and I'll make those square, and then I'll make the hole inside fit the bosses that are on the other half of the universal joint. I'm moving on to the trunnion blocks now, and the first thing that I'm going to do is mill them down to thickness. So I've got that side machined. I'm going to go ahead and take the rest off of the other side. And while I'm getting this set up, I want to say hi to Neil Cooper He is my very first patron on Patreon. So way to go, Neil. If you want to be super cool like Neil, go check out my Patreon page. The link's down in the description. While you're down there, since I'm working on a car part, leave a comment with your best car-related joke. Let's see if we got there. 615 and maybe about 4/10. Let's see where we are on the other side. Just a skosh bigger. 615 and 7/10. Alright, that's good enough for me. I'm not driving this car. After a little bit of tweaking, I've got it to where it fits in here and slides up and down quite nicely. I think that's just about the right amount of fit that we're looking for. It doesn't have a lot of slop one way or the other. It should fit quite nicely, and it fits in both sides. So let me get the other one done just like that, and then we'll move on to the saw cut end. I've set up for the next operation, and I'll just be side milling with this 3/8 end mill. I've also set up a collet stop since I'm going to have to flip these parts around and I've got multiple parts. It's not strictly necessary, but it's really going to make the job go a lot faster. That was the second side of the first part, and now I've taken my measurement, I've put it into my digital readout, and I'm going to go ahead and machine this down to size before I switch to the next part. I'm just about ready to start with the holes in the trunnion blocks, but I don't want to have to keep swapping out my tools. It's much easier to swap out the parts and then put them back in since I'm using a vise stop. With that said, I like to put a little dot on the face of the part that's up against the vise stop. That way I always know what side's up and which way it's oriented in the vise. As you can see, I did that with this one as well. This way, whenever I swap the parts, I always know that that corner goes there and this face goes up. Some of you might ask why this is necessary, and for this part it's not strictly necessary since this is only going to have one hole right in the middle. But if you had a part that had, let's say, a grid of holes, you would want to make sure that you oriented the same way so that your spot drills, your drills, and then say your tapped holes all came out in the same location. Especially for a tap, because a slight misalignment could easily cause a tap to break. Beautiful. I think that's going to be fantastic. I've got the universal joint stuck in my 4-jaw chuck, and I've got it dialed in already. I need to turn off all this extra weld that you see out here. There's a little bit on this side as well. There's some on the inside. I don't know if you guys can see that. And then there's also this very slight taper that I'll also need to clean up. I don't know how close I can get. I'm just going to try to skim this to where it's just over the original surface. I'm not going to try to get down to this because I certainly don't want to make this any smaller. I've also gone ahead and zeroed my digital readout on the original surface, or at least really close to it. So I've set that as 0 and I know where to stop. Of course, this thing was welded, so it's probably going to be a little warped on the outside, but it is what it is. You know, I'll just have to live with what I get. This big old glob of weld here stands really proud of this surface, maybe by about 75 thousandths or roughly 2 millimeters. Now this is going to be an interrupted cut. It's going to be potentially a little bit violent. It's going to hammer a lot, and I'm not holding on to much. So I'm going to take very light cuts because I don't want this thing coming out of the chuck. Well, I got a little bit into the parent material over here. I touched off way out here, and of course this thing warped like crazy with the welding, so hopefully this is okay. There is a metal boot that slides over there, but I'm not sure if it's being just pressed on or if it's being held on by these fittings. I'm going to go ahead and stop there though, since I'm starting to touch quite a bit over here, and I'll move on to the inside. I think I have a little bit more wiggle room here because this is all just clearance for the other half of the universal joint. Hopefully you guys can see the angled portion there. I'm going to try to measure it with a protractor like this, but I can't get this all the way across the piece without just hanging off of one side. So I'm going to break out my 1/2 inch thick parallel again, And I'm going to put that against my protractor and see if I can get this up against the tapered part. This is a little bit juggly. Alright, that feels pretty good. And it looks like the angle's about 15 degrees. I think that's going to be close enough for what I need to do, just cleaning up this weld. Again, I'm not trying to get into the parent material. I just need to get that stuff off of there so the universal joint can swivel. Now I'll go ahead and set my compound to 15 degrees, and I'll bore the inside and clean up that taper all in one shot. As you can see, I have my boring bar stuck out just enough, just the bare minimum of overhang. I've got a little bit of clearance here, and I'll definitely make it past all the weld on the inside. On the end of that last pass, I ended up hitting just on the inside of this little shoulder or lip here. So I went ahead and set that just by eye as Z0. This is the Z-axis along the axis of the machine. And I'm just going to make sure that I stop before I do that again. After all, you can't unshit your pants. So I did end up touching a little bit more than I wanted to on the parent material, but again, I don't think that matters too much, because this is all just clearance on the inside to make sure that that universal joint has plenty of room to swivel. Now I just need to clean up the taper, and this part should be pretty much done. So what I've done here is just gotten eyeball close to the taper with the insert. And I set that as 0, so I have an idea of where I need to end up. This should be quite a bit shy unless this thing's super warped, but I don't know, we'll see in a little bit. From here on out, all cuts are going to be angled using the compound. So that pretty much does it. It's not the prettiest thing, but I think it'll definitely be functional. You can see I touched a bit here, and this was actually 0.010 of an inch shy of where I set 0. So there was a lot of warping going on. But this should be more than good enough after I do a little bit of deburring. Make that a lot of deburring. I've got one of my trunnion blocks chucked up in the forejaw, and what I need to do is radius, or in this case I'm just going to angle the face of this so that it's got clearance against the boot that goes over the universal joint. The print actually calls for 1.5 inch radius, so I drew that out on a piece of paper and cut it out so that I could check it with this. I've actually already gone ahead and set the angle using the first piece, and so I know this is going to be correct. You can see how I've got the compound angled, and I just need to touch off on the face, and I'm going to set this corner over here, or any of the corners, as my X0. I'll make all of my adjustments this way using the carriage hand wheel, and then I just face until I reach the bore that's in the middle. I'm just gonna get close here. I'm gonna 0 my Z. The dimension's not particularly critical. And then I'm going to come out here past the corner and 0 my X. It's not really necessary to 0 the axes, although it is helpful to 0 the Z. But I like to do it anyway because if I accidentally bump something and move one axis that I shouldn't be moving, it's easy to get back to the beginning. Looks pretty good. And like I said, I set this with the first one, so you can see that I've got plenty of clearance. The high spot's actually in the middle, so that I know back over here is definitely going to clear on the universal joint. Now I just need to deburr these and it's ready to go actually. I want to point out too that I used these brass soft jaws over here because I did not want to score up the sides of this part, since that's what's actually sliding up and down in the joint. It's good practice if you ever want to have a non-marring surface. You can make these pretty easily. This is just some shim stock. I didn't have a lot, so it's better actually if you can make it so that it bends around the jaws and then they just don't fall off. I might do a separate video just on that sort of thing. Well, here we go. We've got all the pieces of the universal joint, our trunnion blocks, and our other piece here. Most of the weld anyway is taken off. I've thoroughly deburred everything, and it's a little tricky getting everything put together, getting everything aligned. But yeah, once you get it all in, then you can see it'll move around pretty freely, hopefully. Hopefully this works for him. If not, I'm sure he'll have it back to me to have some modifications done. Thanks for watching. I'll see you next time.